Let's talk about how we name cycloalkenes. So, to name your cycloalkenes, the key is remembering that the carbon carbon double bond gets number one, two. It gets number one, two, but here's the trick. So, that's period, right? The double bond gets one, two every single time. The key is you have to number the double bond, the carbon carbon double bond, in the direction that gives the substituent you encounter first. In this case, you don't have to worry about that. It's just one substituent, the lower number. So one, always remember the double bond gets one, two. But the key is you have to write 1 and 2 in the right direction that gives the substituent you encounter first lower number. In this case, it's one substituent, right? So you number 1, 2 so that the substituent get the lower number. So let's look at what we're talking about when we say that you have to number 1, 2 in the right direction. So you already know double bond gets 1, 2, right? So 1, 2, 3, 4, 5, 6, right? So with blue, double bond gets 1, 2, and your substituent, which is a methyl group, is on carbon number 3. What if we now number 1, 2 in the opposite direction? So let's number 1, 2 in the opposite direction. And this is what I mean by opposite direction. 1, 2, 3, 4, 5, 6. Your methyl group is now on 6. As opposed to when it was blue, we did 1, 2, 3, 4, 5, 6. So you see the direction you put 1, 2 is important. When I do red, it is on 6. Blue, it is on 3. So we're going to number using the numbers associated with blue. So to name this, and we're doing that because with red, my substituent is on 6. If I number 1, 2 in my blue direction, substituent is on 3. So to name this, it's 3. You have to identify where my methyl group is. Ring structure, and the ring has 6 carbons. Cyclo, because it is a ring, and we have 6 carbons. Hexene, because of the double bond. Right? And the double bond is between 1, 2, so you don't need to write the number 1. That's cyclohexene. Let's look at, that's 3-methyl cyclohexene. Let's look at another example. Let's look at this example here. So, I'm going to tell you a rule of thumb, right? When you have, not in this, I'll give it a rule of thumb for another example. It doesn't count in this one, but the next example, I will show you a trick or a rule of thumb, something to use. So for this one, if you number your subs, this one doesn't matter what direction you number it. Your substituents are going to be 1, 2, right? And they are the same substituent. So to name this, I have a methyl group on 1 and a methyl group on 2. So it's going to be 1, 2, dimethyl. My ring has 5 carbons, which means it's a ring, so you must write cyclo. 5 carbons spent, and we have a double bond, so it's pentene. All right, let's do this one. All right, if we have something like this, right, let's try to name this. This is the one I need to teach you a little trick. Whenever you have one substituent, right, on one carbon of the carbon carbon double bond, there's one substituent here, there's none here. There's a hydrogen here. Hydrogen is not a substituent. Whenever this happens, remember you have to number 1, 2 in the direction that gives the substituent you encounter first the lower number, which means every time without fail, if you have a substituent on one of the carbons of the carbon-carbon double bond, that substituent must be number 1. Because I already know 1, 2 is right here. But I'm like, okay, where do I put number 1? Right? You don't even have to play around with it. Number 1 is right here. Because remember, you number 1, 2 in the direction that gives the substituent encounter first the lower number. Which means when I put number 1 here, I am putting 1, 2 by my double bond, and the substituent encounter first is on 1. There's no number here lower than 1. So 1, 2. We could not have done this. 1, 2. Couldn't have done it in that direction. You know why? Because the substituent you encounter first would be on 2. So no, you can't do that. So always remember that you place, always remember to place 1, 2. Number 1 goes on the carbon of the double bond that has the substituent on it. And this rule only applies when you have a carbon-carbon double bond, there's one substituent here. So let's talk about how we name this. So it's going to be, I have 3 methyl groups actually. There's 1 here, 1 here, 1 here. So it's going to be 1, 3, 6, right? Methyl group on 1, 1 on 3, 1 on 6. Since it's 3 groups that are the same, trimethyl, they are methyl group, 6-membered ring, cyclo, hex, double bond, E-N-E. Also, if you see 1, 3, 6 trimethyl, sometimes they put the 1 in, but it's honestly and truly not necessary. If you don't put it, they know that it's actually on. Double bond is between carbon 1 and 2, so you may or may not see that. Here's another example. Excuse me. Here's another example. So I just taught you the trick to this one. 1, 2, 3, 4, 5, 6. Notice where my number 1 went? You don't have to think about it, play around with numbers. No, number 1 has to be here. To name this, you have a methyl group and an ethyl group. Of course, you have to listen in alphabetical order, just like you would have done with a cycloalkane. So you write 3-ethyl. This is the ethyl group. This is the methyl group. On carbon 3, I have an ethyl group. You write that. On carbon 1, I have a methyl group. 6 carbons in the ring. So it's going to be cyclohex. Double bond makes it cyclohexene. Mistake that students commonly make, it's not the number that you put at the beginning. Alphabet.